Okay, so we've been doing a lot of talking about base and height, and we are going to identify which is the base and which is the height. And we're going to start with the classic good old rectangle because I have been sharing that instead of length times width, I prefer base times height. Now, the beauty of a rectangle is it really doesn't matter which is which. It depends on its orientation. So, for example, the way I have it located, the way I have it oriented right now, my base is at the bottom. So this would be my base. Okay. And then my height would be going up the side, right? So this would be the height. Okay. Now, the beauty, I'll use a different color. That color is pretty close to the other color. So we'll use red or pink here, height. Now, if I were to rotate this shape, I could, and then my base would be the bottom and my height would be up the side. So the nice thing about rectangles is it really doesn't matter. The base and the height are interchangeable. And that is unique to rectangles and squares. Obviously, square, I mean, if you have a square, the base and the height are the same. So if I just do a quick sketch of a square, 3 by 3 here, it doesn't really matter. Whichever side you use, it's going to be identical. So if base is 3, height is 3, I can rotate it around. So here would be my base, my height, they're the same. So it really doesn't matter for a square. Okay? Same with a rectangle. If I rotate it around, now my base is at the bottom and my height is at the top. Okay? Now, what happens though when we deal with like parallelograms and triangles? We got to be really careful because the height, what determines a height, is that right angle. Remember how we've been talking about it? This is what determines the height right here. So if I have my base is 1, 2, 3, and my height is 1, 2, 3, there's where they overlap. Okay, that corner, and that is what creates the height. Same with my rectangle. I've got my base 1, 2, 3, 4, 5. I've got my height 1, 2, 3, 4, 5, 6, 7. Here's where they overlap. That's the right angle. We also call that perpendicular. That's a word that we will use throughout the school year. Perpendicular. And perpendicular are two lines that form that right angle, kind of like a T. Okay, so we're looking here at the T. It's just the half of the T, but you can see it. Here's the other one. Okay. Now, what about the diagonals? We got to be really careful because with a diagonal, the diagonals are not the base or the height. So we don't want the diagonals. So I'm going to put those in red. We'll find red. We do not want this or this. Okay, we don't want this, we don't want this, we don't want this, we don't want this. No diagonals. Okay, diagonals are not going to work for the base or the height. So what we're looking for the base is we're looking for a kind of like a flat spot where we can kind of rotate, like put this down. So here's my base. Okay, now my height of my triangle is how tall it is from the base to the point. Here's my point at the top. So I could go straight up the middle, 1, 2, 3, 4, 5, and I can see that that's 5 units. So this would be my height. However, I could also do it on the outside. So I can imagine that my dot is up here, right? Because here's the top of the triangle. Here's the bottom of the triangle. 1, 2, 3, 4, 5. I can also see it out here. It's imaginary. It's like invisible. But if this is the base, here's the height. And you see that perpendicular line. Remember how I told you it's always going to make that nice right angle. See that? Okay, so let's take a look at the parallelogram. So in this situation, my parallelogram, my base is here. Okay. And my height can be found a variety of places. Just like the triangle, I can go straight up. I'm just trying to see how tall the top is from the bottom. I don't want the diagonals, no diagonals, okay? So I could go straight up the middle, 1, 2, 3. So this would be a height. Again, it makes the right angle. I could also go on the outside, 1, 2, 3. Okay, there's that right angle. All I'm doing is counting the measurement between the top and the bottom, and that would be the height. So this one is another example of height right here. Okay. All right, this one's a little tricky because the base is not the diagonal. Remember, no diagonals. In fact, I put that in red. I probably should have put it in yellow. No, we don't want these. These are like not part of our measurement for right now, okay? All right, so let's rotate the paper around, and then now I can see the base. Okay, I could also rotate it this way and the base would be here. So the base is like top or bottom. Depends on the orientation. So this could be the base, but that could be the base too. You just would, upside down, but it would also work. So either one of these line segments, the top or the bottom, could be the base, just like my rectangle, the top or the bottom, top or the bottom. Okay, so let's rotate this around. Here's my base right here. And then again, my height can be found a variety of places. I could go straight up, 1, 2, 3. I could come out, 1, 2, 3. All I'm doing is 1, 2, 3. I'm just finding the distance from the top to the bottom. And sometimes that line can be imaginary and it can be outside of the shape, but it's just as if we were saying, okay, I've got this space up here, I've got this space down here. What's the distance? How far apart are the top and the bottom lines? In this case, you can see that we have 3. So our heights are here. And again, here and here. And again, you can tell because it's always going to make that perpendicular line. It's going to make that nice L. You could take a post-it note and you could line it up in the corner. That's how you know you have the base and the height. See, you don't want that diagonal. All right, so in the next lesson, we're going to take a look at, is it base or height? Let me pull this down. All right, this is actually pretty good. Lesson 5, practice problems. And we want to make sure we're finding the correct labels for the base and the height. Okay. Now, this really doesn't matter. This is kind of a trick question. A is technically correct. We can definitely say A is correct because if I were to rotate this around, the base and the height are here. Remember, they're interchangeable. So yeah, it looks a little weird because you're like, wait a minute, that's not the base. Well, I mean, it could be. So if I just rotate A around, here's my base and here's my height. So just remember that rectangles, it's interchangeable. Okay, so this is a rectangle. And rectangles are special because the base and the height are interchangeable. All right, now look at B. B is a no-no. This is a diagonal, right? That's a diagonal. That's not the height, not the height, okay? No diagonals. So I'm going to say nope. Diagonals are not height. Diagonals are not the height. And again, I can prove it because do you see that this diagonal doesn't make a right angle? See that? See that how it's like obtuse? It does not make a right angle. All right, let's take a look at C. C is great. Now, C is great because we have this base. It's perfect. It's like right on the bottom, so we don't even have to rotate. Like here's the base. And then our height is showing us in a couple different places. So I have height here. This is the height, which is also the same as this. Remember, the height is going to create that right angle, and it's going to tell me the distance between the top and the bottom of the shape. See that? So here's the top, here's the bottom. How far apart are those line segments? In this case, they are 2. So this one is check. C is correct. All right, now D is a little tricky. So look at D because it doesn't look correct. It doesn't look correct, but I'm going to encourage you to look at it in a different orientation. Rotate, and then now we can see a base. Okay, now yes, it is diagonal, but if we were trying to measure it, it would be a base. So if I can't use the graph paper, it's a little harder to use the graph paper, but if I were to measure this with a centimeter ruler, I can see that this straight line, right, this straight line is 3, so that would be my base, and there's my height, okay? The height is perpendicular to the base. That's what I'm looking for. I'm looking for a straight base and a line that forms a right angle. Okay, that one is a tricky one, 100% tricky one. So if you had trouble with D, D is correct. You have to turn it around so the base is at the bottom. And then you'll see it. Okay, so that one was definitely tricky. The key with all three of these is the right angles. Now, they're not showing you the right angle here, but it's kind of in the square, right? See, there's the right angle. So it doesn't really matter if the base is here or here in a rectangle, they're interchangeable. So really the only one that is not correct is B. Okay, let's see if we can create a height for this parallelogram. Again, I love they're telling us the base is right here. So they're saying this is the base. So we just can draw a line that shows the height. And again, everybody could have a slightly different answer. I could draw one here. That would represent the height. So this could be the height. I'm just going to say H for height. I could put it out here. This would also represent the height from here to here. That's the height. Okay, I could put it over here. Here's a height. Remember, the only thing we need to make sure that we do when we're trying to do the height is we want to see how far apart the top and the bottom is. So if this is the base, so here's the bottom, here's the top, how far apart are they? But we need to make sure we make those perpendicular lines. We don't want to use the slanted. See this? That's what we're looking for, those right angles. We don't want the slanted lines. All right, let's see if we can find the area of each parallelogram. A is a parallelogram, but it's a rectangle, a special form of parallelogram. And for this one, I can see the height is 2, and I can see the base is 1, 2, 3, 4, and 2 times 4 is 8. That's an easy one. 8 square units. Okay. All right, for a parallelogram, remember, we learned in the last lesson that if we cut off this triangle and remove it and put it over here, it's a rectangle. These two are both rectangles. It's just this is a special type. It's a parallelogram. And again, if I cut this off and I slide it over here, I've created a rectangle. So all I need is the base and the height. That's all I need is the base times height. So I can see the base is 1, 2, 3, 4, 5. So I'm going just from line segment to line segment across. There's 5 at the bottom. So 5 times the height. And again, we can find the height a few different places. Here's 1, 2, here's 1, 2, here's 1. So there's multiple different places. We could do it right here. Here's another height. Here's another height. Okay. Heights are all the way across. And you can see that this rectangle, the height is the same as this. Okay. So 5 times 2, which is 10. 10 square units. All right. The last one is a little tricky. Got to do a little rotating on this one because this is not the base. I mean, we could make it the base, but we can't count the boxes for this. It won't work because there's partial boxes, and unless there's a ruler, then we can measure it, but we can't. We're just using graph paper. So if we rotate around, we can see here's the base. See that nice straight bottom? So there's 2 here. 1, 2. Now I can see how far apart are my top and my bottom. And in this case, it's like left and right, but this is the base. So this is the base. And then my height is just going to be how tall. How tall is this? So I can go right up the middle if I want. 1, 2, 3, 4. So it's 4 units tall. I can test it out here. 1, 2, 3, 4. I just want to go from the top to the bottom. Okay, top to bottom. So my height is 4. See that? So 2 times 4 is 8. 2 times 4 equals 8 square units. Oh. Okay? All right, so just remember sometimes you might need to rotate a little bit. And that can get kind of tricky when you're working online on a digital paper, because you got to kind of visualize like, all right, this parallelogram, if I just rotate it, it's standing up, and then I can see, okay, there's the base and there's the height. There's the height. Okay? All right, the rest of the practice problems, let's take a look at this one. This is actually a good one. Okay, so it says, if the side that is 6 units long is the base of this parallelogram, what is the corresponding height? So they're telling us the base is the 6. Okay, so here it is. Now there's a top and a bottom to the base, but that's normal. We can have a top and a bottom. So here's the base, the bottom, and it's the same at the top. That's what makes it a parallelogram. It's got to be congruent. We've got to have the same length at the top as we do at the bottom, just like a rectangle. Okay, so I can see the base is 6, so where's the height? Well, I see a couple perpendicular lines here. Here's a perpendicular line, and they want you to believe that this is the height. But remember, they're telling us that the base is the one that's 6 units long. So this is the base, so the height is the 4. The height is going to go straight up from the base, perpendicular. Okay, see the box? That's the height. Now, why is the other one not the height? Why is the other one not the height? Well, it's because it's the wrong base. If I rotate this around, this is not the base and the height. It's even telling us this is the slant. That's the slant of the parallelogram, and we don't want the slants. We don't want the slants, okay? So this would be the slant. All right, and this is the slant. This is the base, this is the height. See how it makes that perfect perpendicular line. Now, again, they are trying to trick you because they are showing you that this line is perpendicular to this line, but that's not the base. They're telling us that this is the base. So we need the line that goes up from the base that makes that perpendicular line, okay? All right, find the area of each parallelogram. We'll end with this because it's super easy. Remember the parallelograms, because they're just like rectangles, base times height. That's all we need, okay? Base times height. Just remember the slant is not the height. That's the key. Slanted, not height, okay? That's like the only thing you really have to remember with parallelograms, that the slanted line is not the height. Okay, so we've got the base 9, height 4. How do I know that that 4 is the height? Because it makes that perpendicular line with the base. So 9 times 4, 36 centimeters squared. Okay? All right, now this one is giving me a slant. Slanted is not the height. I don't want that one. I've got the base and I've got the height. See the perpendicular line forming with the base. I know this is the base because of the arrows. That's usually a signal that this is the base. So it's 5 times 4. 5 times 4 is 20. 20, oh, I'm rushing. 5 times 4 is 20 centimeters squared. Okay, last one. There is no formula here. I don't know. I can't find the area because it's not telling me. I just know it's base times height. So here's the base and here's the height. But you're like, Miss Breen, that looks like the base. Well, no, look, rotate it around. Here's the base. Here's my height. See that? Remember how far apart is the base and the height. And sometimes with your parallelograms, the base may be on the left. You might have to just kind of rotate it around to see it. And our formula is, for this, we're just writing base times height. So it's just base times height. And that's a wrap. Okay, lesson 5. We will be moving on to some more area of parallelograms for lesson 6. And then for lesson 7, we're going to get into triangles. Okay.